Thank you, Teresa. So today we have Steve Hebert from Nimbix. So Steve, why don't you introduce yourself?
Yes, good morning. Thanks, Mohan and Teresa. My name is Steve Hebert. I'm the CEO and co-founder of Nimbix, and we're looking forward to talking with you today about a really innovative solution that we've been working with VMware on with doing HPC on Tanzu. So Mohan, I'll hand it back to you to kick things off, and then I'll dive in a little bit more specifically about the Nimbix solution.
Thank you, Steve. So today we'll look at high-performance computing running on Tanzu, which is our Kubernetes platform, across different clouds, multi-clouds, and then we will layer on top of it Nimbix, which runs the HPC applications. In today's agenda, we're gonna look at traditional HPC, what it entails to do HPC, the infrastructure that it takes to run HPC, the drawbacks of that traditional infrastructure, the capabilities that can be brought forth with modernizing that infrastructure, and how VMware Cloud Foundation and Tanzu can help there. And then we'll look at some of the management capabilities that we bring with Tanzu's mission control and Wavefront, which is their observability platform. Then we look at Nimbix multi-cloud solution and potentially a demo, right? So if you look at traditional HPC architecture, it is most of it is even now bare metal, primarily due to the need for really high performance computing. So in a bare metal infrastructure, typically the components have each component has its own physical server. Depending on the type of application, the components vary. And then some applications require really high speed, low latency networking. That's where you need InfiniBand. Some applications work over traditional Ethernet as well. The traditional hardware refresh cycles for this environment, as you can see, is since it's tightly bound, it usually takes 3 to 4 years of cycles. That means once you buy hardware, you have to use it for the next 3 or 4 years before you get the next generation of the hardware. So, and other things that I want to mention here are things like the login node and the head node. These things are typically part of the infrastructure, and they can be single points of failure. So traditional HPC architecture is pretty static. And and the hardware also, has vulnerabilities in the sense it has single points of failure. So if you look at enterprise HPC today, right, a lot of HPC is a mission critical aspect of many organizations, because that is where a lot of the R&D for the organization happens. And so the infrastructure is pretty complex. So there are a variety of devices that include different CPU types, memory, storage, even high performance networking. We have accelerator cards for networking, things like FPGAs. The GPUs are very common in HPC environments. And there are also multiple workload options. So you have different engines, different schedulers, that are pretty complex and to deploy and manage. The HPC environment itself is pretty dormant and is refreshed only once every 3 years, like I mentioned earlier. This can impact the business because of with slower innovation, the complexity, the higher costs, and the siloed operation, because this is not the typical IT. And so it's different, and so that needs to be managed separately. And almost 80% of the budget usually goes to keep the lights on. So we want to change that. We want to see that how this traditional HPC can evolve and become part of the modern data center, right? So if you look at the road to the modern data center, we can leverage high performance computing capabilities onto the VMware platform, and maybe combine it with all the modern aspects, like VMware Cloud Foundation provides data center resources. We can bring in Kubernetes as the common orchestration engine. And instead of having these applications statically deployed, we can have them containerized. And then these containerized applications make it easy to deploy and easy to run and bring up and tear down as well. So containers provide a lot of the encapsulation capability where the entire application, all its dependencies are within the container. So the installation time, the build out time for traditional HPC, where you actually build the hardware, then deploy the software on top of it, can be reduced drastically by leveraging containers. So even though containers initially came about in the microservices arena, containers can be a great asset in high performance computing. And then other aspects is we see that HPC and AI are also converging along with big data. So this is a big trend, and we want to be able to leverage that. And we want to be able to utilize our hardware to the most possible extent, and by leveraging the capex investment. So we want to be able to have things brought up and toned down dynamically, like in the cloud, even for HPC environment. And by doing that, we are utilizing the hardware and the software in a very capable manner. And we are also accelerating the entire HPC application lifecycle. So that's kind of where we bring in the VMware Cloud Foundation 4 with vSphere 7. It has brought together the worlds of Kubernetes with vSphere. We brought a lot of innovations with it. Traditionally, vSphere serviced virtual machines. Kubernetes has its own ecosystem, and so, but it is the platform of choice for modern applications. And so with vSphere 7, we are bringing, uniting the capabilities of vSphere with Kubernetes. So Kubernetes is embedded into the control plane of vSphere itself. And it provides like a hybrid service framework that delivers a native Kubernetes API for IT managed services. So VMs and containers can run side by side, and it creates a high performing and secure and easy platform for consumers. It provides app level control for policies, CODA, role-based access, and other things for developers. It also provides vSphere level features like HA, vMotion, and DRS. It also provides visibility into vCenter for Kubernetes cluster and containers and also existing VMs. So it kind of helps bridge the gap between the developer on the left-hand side and the IT operator on the right-hand side. And it kind of brings both of these worlds together. And now the developers and operators can collaborate to gain increased visibility and be able to troubleshoot and get to the root cause of problems as soon as possible. So now we look at the world of multi-cloud, right? So VMware as a company actually plays a big role in on-premises as well as in the cloud and cloud world. So we have our own capabilities that exist. VMware Cloud exists on AWS, on Azure, Google Cloud, Oracle Cloud, and a lot of other VCPP partners as well. So in this, so the Tanzu can run on all these clouds as well. So what do we need, right? Imagine that you're deploying Kubernetes clusters across different clouds, and you want these things to be able to manage centrally and integrated together, right? So we have this component called Tanzu Mission Control. So Tanzu Mission Control gives teams self-service capabilities to spin up their own Kubernetes clusters. It also helps you keep track of all their services using a component called workspaces. Workspaces work across clusters to give teams to group things together, and also to kind of specify policies and management frameworks over all these clusters. It also allows the teams and operations to assign policy in a hierarchical way. And there's a global level, a cluster level, and a workspace level. So Tanzu Mission Control lets you, even if you have, like, let's say you have Kubernetes clusters for a particular application running on-prem, one instance, one cluster running in AWS, another one running on, let's say, VMC on Dell EMC. We have the capability of having a single pane of glass and manage these together and group these aspects in the form of workspaces. The next aspect that's important is monitoring, right? So when you have all these applications deployed and running, traditional monitoring is what you look for in legacy applications, where you're actually looking for some external signs of failure, and then you react. In the modern world, it's a lot more complex. There are so many different components, and all these components are deployed in individual services. And it's important to be able to monitor all these capabilities individually and be able to also aggregate these capabilities. And this is kind of what we call as modern observability. This is required to be able to effectively manage modern applications. And so that's kind of where we come up with observability. Observability can be defined as the ability to see everything. With observability, you can look at your cloud apps environment, and you're able to troubleshoot and look at all aspects and be able to look at the relationship between different services and the applications in an effective manner. So what VMware provides in this space is what we call as Tanzu Observability. It used to be called Wavefront. And this provides you a cloud-native analytics and monitoring platform that is built from the ground up to support the needs of the modern cloud application. So in this case, we talk about modern cloud apps, but in this solution, actually, we are deploying high-performance computing on top of the Tanzu Kubernetes. And so we are going to be able to monitor and manage these applications with Tanzu Observability. And then it is a very advanced platform, and it provides all these different capabilities that you see below. So now we'll look at the type of solution. Now imagine you have Tanzu Kubernetes, you have Tanzu Mission Control, and you have Wavefront for observability. Now, how do we take this and build an enterprise class HPC platform? So this is kind of, this shows a schematic of the architecture that we deployed. We actually deployed this solution in our VMware Cloud Solutions Labs, and we have multiple clouds connected here. We had an on-premises vSphere environment with VCF4. We had a VMware Cloud on AWS, where we use Tanzu Kubernetes Grid, multi-cloud version. And then we created open source Kubernetes clusters on bare metal. So we are trying to emulate all the different aspects of HPC. Some parts of HPC will be bare metal. Some of them can run on vSphere and on the cloud platforms. So, and on the right-hand side, you see Tanzu Mission Control and Wavefront for management and observability. And then you have infrastructure admins who control the infrastructure. On top of that, we layer HPC. So there are HPC application developers and users. We're going to talk about Nimbix shortly, and then that is the application that's going to orchestrate all the HPC applications across these clouds and manage it for you. So now I'll turn it over to Steve to continue the discussion.
Great. Thank you, Mohan.
I'll stop sharing.
Okay. All right. Good morning again, everyone, and thanks, Mohan. So in this first segment, Mohan talked about the really important infrastructure layer that HPC requires, and now with looking at multi-cloud and hybrid, the benefits of the Tanzu solution to manage that infrastructure. And I'm going to spend my time talking about the application layer, which is where Jarvis XE comes in. And I'll talk a little bit, first just introduce you to Nimbix. And as a cloud provider ourselves for over a decade, we've been focused on a class of computing, this HPC and accelerated computing for many years. And our platform technology has been powered by Jarvis, a container native platform, and obviously extremely important in the modern infrastructure and data center world. The Jarvis XE solution, which I'll talk about for our enterprise software component that is layers in with Tanzu, is what I'll cover today. And of course, our platform has been recognized as a leading platform, both in our technology and software for many years, having worked with enterprises all over the world. So let me spend a minute talking about, I guess, first why HPC is important as a workload. You can see here in this source, this data is from Hyperion, and traditionally HPC as a market has been dominated by supercomputing and on-prem infrastructures. And obviously we're seeing that bleed into cloud because customers' demand for these use cases is accelerating. And the reason it's accelerating is because all our enterprises are now requiring computation around the data that they're analyzing, right, in all of their lines of business. Whether you're an aerospace company designing new planes, new jets, new propulsion systems, automotive industry building new cars, electrification of cars, autonomous driving, life sciences, you have the pharmaceutical companies, bioinformatics, genomics. All of these use cases are now not only exploding in their demand, but also their computational requirements are growing. So for many years, a lot of these workloads were supportable on a single desktop computer. The more advanced ones required clusters to accelerate that computing. And now with the increased complexity of these models that are modeling more and more advanced technologies, we simply need more computational horsepower. And that's where traditional supercomputing has, solved that problem. You also are seeing the advent of deep learning and AI pretty much entering every single enterprise use case, whether you're a retailer analyzing the behavior of consumers, your car companies figuring out how to train neural networks to self-drive vehicles. In almost every imaginable use case, we're seeing this. And so this drives accelerated computation, things like novel infrastructure with GPUs to accelerate it, or FPGAs to accelerate inference of those things. And this, of course, brings increased complexity. So the point here is this is going to continue to accelerate over time, this use case. And that's why the solution to make it easy for enterprises to seamlessly adopt these new technologies and move to cloud is extremely important. So I'm going to circle back for a minute and touch on a couple of the slides that Mohan mentioned at the beginning of the call around traditional HPC infrastructure and use cases. So imagine, again, you're an oil and gas company or any company doing advanced computation. You normally have historically bought either supercomputers from, say, Cray or HPE or Dell, or you've assembled clusters of servers in your data centers interconnected by Ethernet or other advanced networking technologies. You have monolithic head nodes that, as Mohan indicated, sometimes are single points of failure. But again, this tends to be a very static infrastructure. They're heavily used for computation. They usually operate 24/7. But with the increased of elastic demand for computation, more and more enterprises want to continue to invest in these on-prem solutions, but also seamlessly move between their on-prem infrastructure and cloud. So let's talk about some of these new challenges to traditional HPC. So we have, again, this historical infrastructure where you have your data stored locally, usually, and sometimes this is petabytes of data. You have your applications that are very unique to your domain, whether it's data science, whether it's simulation, whether you're partnered with large enterprise ISVs like Ansys or Dassault or Siemens. These tend to be installed and managed by HPC IT admins on-prem. But now you want to scale beyond a single location. Maybe you have multiple clusters in different parts of the world for your engineering teams. You probably want to replicate all of these workflows that have been curated for many years and figure out how do we move those to a cloud. And then you need to then manage performance deltas between your very high-end on-prem systems maybe and the different types of compute available from various different cloud providers. Obviously, with this becomes increased complexity, different profiles of how the workloads behave on those clouds. And then ultimately, how do you start to converge these technologies with things like Kubernetes for deep learning and traditional IT web services? So traditional IT may be deploying Tanzu on-prem for other use cases, but HPC has traditionally been siloed. So now how do we bring these together under a single unified platform to do that? So from here, let's talk a little bit about the evolution of the hyperscale clouds today. And since Nimbix has been in this business ourselves with purpose-built infrastructure, we've seen the evolution of the various cloud providers developing and deploying infrastructure increasingly capable for high-performance workloads. So 5-10 years ago, if you wanted to run an HPC simulation in AWS, you could probably do it, but on a virtual CPU and memory, it would have run slower, cost a lot of money, and been very inefficient relative to an on-prem HPC cluster. Fast forward to today, we have very modern CPUs of all different types, ARM, AMD, Power, Intel, and we have different acceleration options with GPUs, things like FPGAs, which are now seeing show up in the hyperscale clouds as well. And then also faster and faster and lower latency networking interconnect between the compute nodes in their data centers. But it's still complex to consume these. If you've ever, as many of you I'm sure have, been into the consoles of the various providers, they have very broad offerings, and they can be complex to figure out how to best optimize for the HPC use cases. So from the point of view of the enterprise, from the end customer, what's the ideal state? Well, the ideal state is how do I take my HPC applications and workflows, MATLAB, ANSYS, Siemens, Dassault, maybe in-house algorithms that you've curated for many years, and how do you replicate those seamlessly across any compute endpoint? And therefore, balance the economics of what you're processing on-prem and what you might be now being able to process in the cloud. And then preserving those applications and workflows that instead of redeveloping them to fit a new computing model, right? The idea is you don't want to have to necessarily force a change just to consume cloud. You want to be able to move them seamlessly between. Ideally, you can also limit customizations for any given infrastructure. So if you wanted to burst to, say, Amazon Web Services, you don't want to necessarily build a bunch of expensive plumbing just to talk to the Amazon cloud when you may want to talk to other endpoints in the future. And then ultimately, how do you drive enterprise level tracking, management, reporting, analytics across all your resources globally, whether it's running in AWS or Google or on-prem or in multiple on-prem data centers. So this is where enterprises want to go. So looking at what some of these attributes might look like as compared to maybe alternative solutions, what customers I think are important and what we've seen through surveys even from some of the third-party marketing firms are obviously most important of this topic today is hybrid and multi-cloud, right? How do I go hybrid between on-prem and cloud and maybe even multi-cloud? How do I simplify it? How do I make it easy to consume for my engineers and scientists? Do I have not just a software as a service endpoint, but how do I make this a platform that I can actually load new workflows on, build new applications to support, and be able to extend this seamlessly in an open fashion? Versus the traditional approaches that we alluded to certainly can be done in-house, and there are customers who choose to do some scaffolding and plumbing on their own, but you tend to lose some of the benefits of agility, ease of use, and flexibility and portability across clouds. A big part of this effort for enterprises is modern application deployment. And I want to make a point here that it's not just about new container native apps. And I think Mohan made this point as well. There's also many legacy HPC applications that are not container native that you want to be able to containerize and then adapt to that. And that's exactly what I'll talk about in a minute that the Jarvis XE solution is. And so you can see here, what ideally you start to create an HPC model that looks a lot like, almost like a mobile phone model where you have a Play Store, an App Store, and a device, and you can synchronize these apps across these devices. And similarly, you're going to see this same type of capability enabled through the Nimbix and VMware solution. So I'm going to get into a little bit more now about the actual platform that we call Jarvis XE. This is an enterprise HPC software stack that deploys with Kubernetes as the infrastructure layer. This brings industry-leading, very tried and true over many years, container-native technology to any data center or any cloud. And it enables this seamless synchronization of these HPC applications and workflows. And when I say HPC, I also include things like AI and deep learning and data science use cases. It enables rapid deployment and rapid productivity for end users in the enterprise. And obviously, most importantly, is it deploys seamlessly with VMware Tanzu. And to Mohan's point, we've deployed this across multi-cloud endpoints. It's super easy to deploy within the Tanzu environment, and of course brings that point of observability from the Tanzu point on the infrastructure layer, and from the Jarvis XE point to the HPC administrative layer in the application and workload layer. So a little bit more on the architecture for hybrid cloud. We have a concept that we call the upstream or control plane for Jarvis XE, and then the downstream, which can be any compute endpoint that is federated to the upstream or connected, and then allows the synchronization to occur. In the control plane, we provide a single pane of glass, sort of like the Tanzu Mission Control Observability for the infrastructure layer. Jarvis XE's control plane provides this at the end user layer and the IT HPC admin layer. This can be Nimbix managed as a service via Nimbix Cloud, but also deployed and self-managed by our customers through the Jarvis XE software stack. I'll talk a little bit more in a minute about some of these key, well, here it is, key features of the actual platform. And this is a bit of a busy slide, but it's packed with a lot of capability that's really important for that desired state of enterprises looking to modernize their HPC. The first is, importantly, the user interface and the API, the top level API, and then the management portal. So uniquely, this provides, and we found in talking to many enterprises, single sign-on with authentication and identity providers synchronizing with the Active Directory and LDAP solutions of the enterprise is really important. And this is much harder to do in a hybrid cloud environment, traditional hybrid cloud environment, in a DIY scenario. So this enables customers to essentially have single sign-on. They have all of the authentication through their standard IT practices, full audit logging, and this is not just of users and administrative actions, but down to the job and infrastructure level for the HPC use cases. And it's all completely self-service for the users and self-service for the admin. Importantly also is deployment automation. So we don't want our software to be complicated to deploy and install. So we've created a ton of automation around the deployment. And obviously this is a huge benefit of pairing it with the VMware Tanzu solution, is because we can create automation through the entire life cycle of the infrastructure, from whether it's on-prem or in cloud. And then a couple, two more points on the slide is that the unique scheduling capabilities of Jarvis XE relative to traditional HPC schedulers is it is hybrid multi-cloud by design, and it scales out across a global federated compute infrastructure. And no other platform is capable of this today and in the same way. And so it allows for an immense amount of flexibility for our customers. And then finally, and I'll talk more about this in a minute, when you deploy Jarvis XE, we have an application marketplace called HyperHub that synchronizes these applications in many, many industry standard applications automatically to these compute endpoints. So the benefits of this solution for our customers are several, but I want to highlight, really the ease of use and the simplified experience. If you think about even Kubernetes, right? Kubernetes, as powerful as it is, and as powerful as the APIs are, it's not necessarily the layer you want to expose to your end users, like your domain experts in the enterprise. What they are typically used to interacting with is the application interfaces on their desktop. And so this is the kind of user experience that we want our customers to enjoy, is point and click workflows on any infrastructure. They click, they scale, and they run, and it simply and it stays continuously up to date through the HyperHub catalog. We've also dramatically simplified the administration for both HPC and IT admins. And this includes by providing a SaaS interface for their end users, their constituents, and also a unified platform for multi-cloud. Certainly, as I indicated, streamlined application distribution and deployment. This is not just about an existing catalog. It's also about an HPC. For those of you who have customers that have these types of use cases, many curate their own workloads, their own workflows, and their own applications. So you need to have that platform as a service layer, and then be able to seamlessly distribute those across your compute endpoints. And then ideally just reduce infrastructure complexity, which ultimately saves cost, which is obviously a hugely important economic benefit. So I'll talk a bit about the HyperHub application marketplace. And the screenshot, and I'm going to hopefully have time to show you a very quick demonstration of the actual portal. You can see it looks very much like an app store or a marketplace that you might see on your cell phone, or in any kind of typical marketplace where you're consuming applications. And the idea is that you want these through this single control plane, this single pane of glass, to run in any federated compute zone, whether you're running in a Amazon region, a different cloud provider, a different geo, or a different physical bare metal data center. It's the same interface that a user logs into. We have built-in support for auto-scaling these applications, including all of the performance tuning you would typically expect in a high-performance HPC app. One thing that's really important and often overlooked is we have native accelerator support for both GPU, FPGA, and by the way, it's not mentioned here, but also modern silicon from any type of provider, whether it's AI devices, TPUs from Google, any type of modern inference device. And this is going to become, as I've indicated, increasingly important. So GPUs have been around for a while, but you're seeing new capabilities. You'll read press about the cloud providers introducing their own AI inference devices. And Jarvis XE with HyperHub has native support for these built in. Obviously, point and click workflows as opposed to infrastructure layer consumption from the end users and synchronization. Additionally, HyperHub is about building and accelerating the ecosystem of application providers. So many of our ISV partners are actually curating their own software apps in the HyperHub ecosystem with Jarvis XE. And what this means is there's no more downloading and deploying of these applications in a monolithic cluster in one location. It's simply inherited through HyperHub by the compute endpoint with the entitlements that are licensed by those end users. So it enables effectively end users to access this entire catalog on any infrastructure. And then, of course, you can use this catalog to curate your own workflows and your own applications, which many of our customers do today. So Jarvis XE is a complete HPC and AI platform solution. And when you pair it with the VMware Tanzu, which brings that manageability of the Kubernetes layer into a complete enterprise solution for hybrid cloud HPC. And so when you license Jarvis XE, you get the control plane that I mentioned, that user interface for management, the end users, the single pane of glass. Obviously, it has all of the capabilities around single sign-on for the identity providers of those enterprises. It provides a processing API, which includes a batch API. So rather than using, for example, the native cloud providers' batch APIs to interact with their clouds as a single cloud, this processing API allows it to be a multi-cloud, multi-endpoint. For example, you couldn't submit batch jobs on your own supercomputer or your own cluster using an Amazon batch API, for example, but you can use the Jarvis API to do that across all infrastructures. Both software as a service and platform as a service, a multi-cloud management at the application layer. Tanzu obviously brings this solution at the infrastructure layer. Very unique capabilities around global license-based queuing. This is really important for companies that are spending millions of dollars in enterprise licenses from their domain ISVs, like in simulation, where you want to have users maximize the dollars you've invested in those licenses and entitlements to run it anywhere in the world. And of course, with Nimbix Cloud Everywhere, which I'll talk about in just a second, this is a Nimbix managed solution where users can basically log in, open an account, and point and go with Nimbix directly. But you can also use what we call Jarvis Cloud Pak with any Tanzu or Kubernetes enabled endpoint and pair it with a Nimbix managed control plane if a customer chose not to license the full control plane and deploy it themselves. So 3 easy ways for enabling hybrid and multi-cloud containerized HPC. So I just alluded to sort of a very sort of novice beginner's approach, which would be through what we call Nimbix Cloud Everywhere initiative, which is really an on-demand per user based. And it's what I'm going to show you in just a second, just because it's easy to log into and demo. But you can actually start in minutes, and it's more for the domain users in a given enterprise. The other option is for licensing Jarvis XE with the HyperHub application marketplace, which is an annual software license and would be licensed and can be sold jointly with the VMware Tanzu components as well. And it's for our enterprise customers who want to deploy and control and run their own effectively multi-cloud HPC environment. And then the third way is the Jarvis Cloud Pak, which can be used obviously with Jarvis XE for extending into multiple endpoints, or used with the Nimbix Cloud control plane. If you are a technical person or even non-technical, and you want to learn more about how HPC works and can work with Kubernetes, and we're seeing more and more convergence with these types of workloads, particularly with the advent of deep learning on Kubernetes. This is a fantastic white paper that was written by our CTO, Leo Reiter, that talks about some of the details and considerations when using Kubernetes. Because for anyone who's been in HPC a long time, probably will have a lot of questions, right, about the traditional way of doing HPC and potentially the modern way of converging it with Kubernetes. And we're seeing more and more academic work going on in this area, meaning just in terms of the technology. And obviously, we have an opportunity here in this community to have your hands on the technology with Tanzu and Jarvis XE. And then before I cut over to a very brief demo, a few resources and calls to action. For more information on the combined Nimbix and VMware solution, there is a great blog post that walks through some of the details of the deployment. that we've done. I believe there's a video that's been produced that shows a demo of the entire solution. I'm only today going to be able to show you just the Jarvis XE portion of that. And then some contacts for you if you have interest in getting a more detailed deep dive on the demo, or perhaps have partners, customers that may be using HPC or have HPC as one of their current use cases in their IT infrastructure that you might like more information to present this solution with. So with that, let me quickly swap screens and okay. So just to very quickly show you what the end user and would experience. I'm just going to log in to the Nimbix platform. Now, keep in mind what I'm showing you today. This is the Nimbix platform hosted and run by Nimbix, but the actual software can be deployed Jarvis XE with Tanzu on any infrastructure. So what you're going to see here is what I showed some screenshots of is the application marketplace, and I can actually scroll through a number of different industry domain applications, and my computer's getting a little laggy here from the Zoom, but what I want to show you is that it's workflow driven. So if you're a domain user and you actually want to run an application or a workload, you simply click on the app card and it gives you a number of endpoints associated with that application. So you can see that this is the SaaS portion of the capability. And what's really important to note here is that it can be run both interactively in your browser. So in other words, presenting you almost like a cloud desktop that's running your application, or it can run in a batch fashion, whether you're doing a deep learning model training exercise or a traditional scale out HPC application. You can submit that job and fire and forget about it. And the actual where that job lands and whether it's on-prem or in a multi-cloud environment is completely definable by the enterprise customer, right? So within the administrative control panels, this is where it gets configured. And you'll see here, I'm in my US 01 zone. That zone could be my on-prem cluster. I could have another zone sitting out on AWS or Google or Azure. And those, and you can actually give your end users, you can manage the end user accounts based on where they're entitled to actually run their work. So there's a ton of administrative control in the platform. So if I flip over to the dashboard, this is what an end user would see that's a consumer if you're a data scientist or an engineer. And you can see here that I've just run this simple Ubuntu Linux desktop. And it's literally deployed, and in this case, I've actually run it in a remote cloud endpoint. But you can see I can actually just click inside of that workspace, and it's going to open up a new browser tab, and I can drop right into this desktop and use the application as though it's sitting on my local computer. So what's unique about this is you can actually have a massively powerful machine with GPUs, FPGAs or other devices available by the infrastructure, but you could use your netbook or iPad to actually connect to that and run your high performance application completely in this remote fashion. And so obviously this is all for the end users. You can spawn many jobs, whatever your entitlements are enabled from your IT admin, in terms of limitations on machine types, machine counts, and that's really just for accounting controls that admins may want to put in place for their end users. Additionally, if you were running a batch workflow, the batch endpoints would simply show a live tail of your output of the application running on that compute infrastructure. That workload may be running across thousands of CPU cores on hundreds of servers, but you're going to see a window as an end user in your portal here that actually is showing your live output as it's crunching your numbers and operating on your data. One other quick point that I think would be worth showing is if you were to use a workload here, and if I were to actually provision, this is where I actually have a list of the machines that are defined, again, by the admin of the platform, whether it's in their data center or on a cloud. And here's a few. You can see I've got some nifty ones with some high-powered GPUs, different CPU options that are available, and this is completely customizable in the platform. And note that I can scale this particular application to 20 nodes for this one, but we have other applications that will enable scaling to hundreds and hundreds of compute nodes. One other thing worth mentioning is from a storage, I've got this concept called vaults in Jarvis XE, which is persistent data storage. And this is really important, and it's a typical question you may get is, what do I do with my data? Where does my data go? Well, the data goes into your persistent vault. This is every endpoint has an automatic creation of ephemeral. Ephemeral just means that when the stuff is deprovisioned automatically, the data goes away. But certainly, there's customers can have multiple vaults, and these are configurable by IT admin. And then, of course, the preview submission is just really shows the API. And the API can be used programmatically without even coming to the actual portal itself. And we have a lot of customers that create automations with the API here. So the last thing I'll show, and we'll leave the last few minutes for Q&A, is push to compute. And push to compute is the PaaS portion of the platform, and where this is where customers and partners in the HyperHub ecosystem can create, publish, and deploy their own containerized applications. You can see here that I can actually authenticate to a Docker registry, Docker Hub. In this case, I'm actually authenticated to NVIDIA's GPU container registry, where they have a lot of optimized high performance GPU accelerated workloads. And this can be any registry, even a privately hosted one. But it allows customers to actually build their own applications and workflows. And so you saw all those app cards in my marketplace. This is an HPC molecular dynamics application that I just happened to pull that uses GPUs to accelerate it. But this can be any code base that a customer chooses to deploy on. And many of our customers, you can see it has this little lock icon, which simply means that this is only available to the specific end user, or shared maybe amongst their internal team, versus a public application in the HyperHub marketplace, which would synchronize to any endpoint where entitlements were offered. And so, in short, there's also, and I won't go through all of it, we'll save it for hopefully if you're interested in an additional demonstration, a ton of administrative features and capabilities at the application level, the account and enterprise level, that are all customizable by your customers who are deploying this in a multi-cloud and hybrid use case. So with that, I'm going to stop sharing my screen and let me recast the contact screen. And we can open it up for any questions. Mohan, I'll hand it back to you in case you had any other comments on the resources and calls to action.
Yeah, basically what Steve showed us, we've actually were able to deploy on a VMware Tanzu infrastructure across the multi-cloud, and you can see that the link to that solution that we built. It's got all the details, and so it's a great combination here that we've spoken about of VMware Tanzu capabilities along with Nimbix Jarvis capabilities that can layer on top and provide a great HPC platform for the modern infrastructure.